Hello everyone. In this video, we are diving into something every programming language needs: arithmetic and logical operations. We'll look at how math works in Rust and how to write logical conditions using booleans. Let's get into it. Let's start with the simplest: adding two numbers. We are declaring variable a with the value 5 and b with 2 and putting the sum into the variable x and print it. To add two values, we use the plus symbol and you can see the output as 7. Now let's change the symbol to minus for subtraction. The output is 3 as expected. Star, which is asterisk, is the symbol for multiplication. This prints 10 as the answer. We use forward slash for division. Let's change that and see what it prints. 5 divided by 2 is 2.5, but here it prints 2. If you remember from the last video that if we don't mention the data type and assign an integer value, then by default it takes the data type as i32. Now since we are dividing an integer value by an integer, the answer also gives an integer, in this case the quotient. To get the remainder, we use the modulus operator, which is the percentage symbol. And the answer should be 5 minus 2 times 2, 4, that is 1. One thing I should mention here, if you try to perform an operation between two different data types, then the program won't run and will throw a type mismatch error. For example, if we try to add an i32 and an i64 value, then it won't work. The simple workaround will be using i32 as an i64 value. This can be done easily by converting one of the operands to match the data type. It can be done by using the as keyword. Here we are changing i32 to i64. It is preferable to convert to a higher data type so that the value can be accommodated. Now it works fine. Next up, logical operators. Let's see logical AND first. Logical operators work on boolean values. The value of logical AND will be evaluated to true only and only if both the operands are true. We are performing logical AND with a true and a false value here, so the answer is false. If we use logical OR, then in this case the answer will be true. This is because if either of the value is true, then it will be evaluated to true. Logical NOT is simple. It works on a single value and the answer is just the complement. A logical OR B was true, now complementing it gives false. We can also use just the single variable and it complements that as well. Now let's look at the comparison operators. To denote equality between two values, we use double equals. If you are coming from another programming language like Java, you may have question regarding this equality operator. For now, since we just covered the primitive data types only, this operator just compares the values of two variables. That is why here true and false are not equal. So the answer is false. We will further discuss about equality when we will learn traits. Like equals, we also have not equals operator, which is an exclamation followed by an equals symbol. Since the values of a and b are not equal, the answer is true. Next we have greater than operator using the closing angle bracket. Here I am using two integer values. Since 5 is greater than 2, so the answer is true. I must mention that if I would have kept the previous values, that is a equal to true and b equal to false, then also a greater than b would stand true. This is because internally true is denoted by the value 1 and false is denoted by 0. If we see less than operator, it is exactly opposite to the greater than. Using opening angle bracket, we can see a is not less than b. So the answer is false. We can also check greater than equals and less than equals by using the equals symbol after the angle brackets. I am making both the values same to show you the equality here. So in both cases, the answer will be true. We are done with arithmetic, comparison, and logical operators. Now let's look into the bitwise operators. If that sounds intimidating to you, don't worry. We'll break it down using the binary numbers, because that's where bitwise operators actually make the most sense. So first, what exactly are bitwise operators? In short, they are operations that work on the binary representation of numbers bit by bit. That's different from regular arithmetic operators like addition or multiplication, which work on the entire number as a whole. First up is the bitwise AND operator, and it is denoted by the symbol ampersand. It compares two bits and returns 1 if both bits are 1. This is the truth table of bitwise AND operation. In binary, since we only have two numbers, there can only be four possible combinations. Here you can see result is 1 only when both the inputs are 1. In this code, we are using 010 and 101. For bit by bit, if we check the result, it will become 0. If we change the value a from 010 to 011, we will get the answer as 1. Note the printed value is in decimal. Now if we perform bitwise OR operation on the same two values, we will get the answer 7 in decimal. This is because in bitwise OR operation, 1 will be returned if either of the value is 1. In this case, the result is 111 in binary, which if you convert into decimal will give you 7. In this video, I'm not going to explain how to convert binary to decimal or the other way around, but you can check that out in Google. Here is the truth table for bitwise OR operation. In this example, both the values are of same number of bits. So if one of them is larger, you can consider the other number prefixed with 0 to match the same number of bits. Then we have bitwise XOR operation. Some may pronounce it as XOR, but it's the same thing, which stands for exclusive OR. It returns 1 only if both the bits are different. In the truth table, you can see result is 1 when both input values are different. Exclusive OR is performed by using the caret symbol. The bitwise NOT operator is similar to the logical NOT, using the exclamation mark, just that it will complement all the bits in the number. Here we are complementing the value 011. This results to 100, which is 4 in decimal. But then why the program is returning -4? Again, by default, Rust considers this value to be a signed 32-bit number. So 011 is representing as this number in the compiler. So if we complement them, it will be this number. This is the 2's complement representation of -4. Hence, the answer which is appearing is correct. In the bitwise left shift, the bits are shifted to left by a certain number of values. Here we are shifting the value of a by 1 bit. In this case, what happens is whatever bit is shifted out of the number is discarded to the left and 0 gets added to the right. So 011 becomes 110 and the answer is 6. Similarly, for shift right, the same thing happens at the exact opposite direction, that is to the right. Bitwise operators let you manipulate the individual bits, those ones and zeros that make up your number. And that's why explaining them using binary just makes more sense. It shows you exactly what is happening under the hood. But that doesn't mean we cannot perform this on a decimal number. The compiler will perform the operations on binary representation of those decimal numbers. It is something for you to try out and let me know in the comments. Our last topic are the spatial assignment operators. The compound assignment operators are a mix of arithmetic and assignment operator. This is used as a shorthand to perform the arithmetic operation and also assigning to the same variable. Here, in this program, we are declaring a variable a with the value 7. Then we are using plus equals to add 1 to the variable a and assign it back to a. So the answer would become 8. Now, before running this program, do you think everything is correct based on whatever we have learned so far? Let's try to run it and see what happens. And it throws an error. It also shows the reason: cannot assign twice to immutable variable a. It also provides a suggestion as well that consider making this binding mutable. We have learned this previously in Rust. Every variable declared is by default immutable. So if you want to change the value, you have to explicitly mention that by using the mute keyword. Let's correct that and run the code. Now the answer is 8. So this is how we perform an operation at the same time assigning the value back to the variable. Same we can do this for subtraction. And the answer is 6. For this, we can perform operation by using any number, not just one. Let's try multiplying with 2. And the answer is 2 times 7, that is 14. We can also perform the integer division as well as the modulus operation in the same way. So that's all the arithmetic and logical operations in Rust. In the screen, here is a list of all the symbols. You can pause the video and take a screenshot to refer it later. I would encourage you to try it yourself by using your own values. That's all for now. We will see you in the next video.